In recent years, technology has evolved enormously. This is because of the arrival of machine learning, which has allowed computers to behave and learn as humans do, and further improve their learning capacity through data, inputs in the form of interactions and real world observations. The rate of defaults and charge offs are at their highest, which is why the need for an accurate credit risk assessment model more than ever. For example, every year more than 1 million student loans go into default in the United States, and so their education debt has increased 3 times in the last 10 years. The bad loans and loan defaults hinder the stability and profitability of financial institutions and eventually slow down the economic growth. As a result, we can really see that loan default is a very serious issue.
The objective of this paper was to create a model that includes a proper dimensionality reduction procedure, parameter tuning, noise handling, and imbalanced dataset. These are fundamentals for developing a model which aims to assist in credit risk assessment. In this paper, the dataset was obtained from Lending Club, which is an established and recognized peer-to-peer credit lending institution located in the USA. Parameter tuning noise handling was performed using a grid search of cross-validation, and the problem of an imbalanced dataset was effectively handled. A comparative supervised classification of algorithms was made using different dimensionality reduction methods, and the optimum combination was selected from credit risk assessment.
The author mentions that in database, 86% of the data were not default, which could cause a risk of imbalance. The author drew our attention that he used the smoke technique. It was just up to upsample instances of minority class in order to mitigate this problem. It's important to note that he uses the smoke technique only for the train set. The RFECV, a featuring selection method, and the PCA, a featuring extraction algorithm, was chosen as the two candidates for a comparison. The first method performs recursive features elimination with a cross-validation loop to extract the optimate features. The second is a machine learning algorithm which can be used to reduce dimensionally through the results of the model based on the RFECV will be compared with the models of the PCA to obtain the optimal combination. The author uses the grind search CB to turn the hyperparameters. They did this for the only purpose of showing the effectiveness of the tune classifiers compared to the raters in their basic form. A precise classifier is the basement of any machine learning model, such as support vector machine, SVM, the logistic regression, the OR, the extreme gradient boosting, the XGB, and random forest, the RF, where the four algorithms select for this analysis.
In the results, we see that the models using the RF-ECB show more promise than the PCA models in accuracy classifying the loan cases. They overcome the PCA-based models by a very small margin. The model's accuracy was evaluated by the author through a 5-fold cross-validation, and the hyperparameters will be adjusted using the green search CB, which will allow to obtain a cross-validation evaluation with more balanced and accurate result, in order to be able to guarantee the best possible performance of each classifier in this sense. After using green search CB, the test result we see in all the cases, the classifier using the RF-ECB once again outperformed the classification models using the PCA method. However, the author mentioned that in the AUC and the F1 evaluation method, the SVM model stand out from the rest. This is the highest score of any model in all the experimentation of this paper. So in conclusion, with this test, the author clearly indicates that the RFECB combined with the SVM is the more optimal option for evaluating the credit risk.